Okay guys, we're going to do a lesson over matrices. I don't think you did matrices in Algebra 1, and these are on the ACT, and we also use them in Algebra 2 to help us solve systems. So this is just going to be like a quick overview of matrices, and we'll talk about how they look on the ACT. So first of all, a matrix, or matrices if it's plural, is a rectangular array of numbers written within brackets. I always define it as a rectangular array of numbers arranged in rows and columns. Okay, but this is the definition that one of the Algebra 2 books that I had in the classroom uses, but I always remembered it as a rectangular array of numbers written in rows and columns. You can represent a matrix with a capital letter, so we could call this matrix capital letter A, so matrix A, and we can classify it by dimensions. This is where it's really important that you remember rows by columns, because everything hinges on rows by columns. So if I look at this matrix and I want to classify it by its dimensions, then I'm going to look to see how many rows it has. Rows go side to side, so it has 2 rows. And columns go up and down like columns on a house. So this is 1, 2, 3 columns. So this is a 2 by 3 matrix. Each matrix, or each number in a matrix, it could be a variable, but anything that's in these spots in a matrix is called a matrix element. So let's look to see if you know how to determine the dimensions. Remember, dimensions are rows by columns. So if I look at example 1, I have 1, 2, 3 rows. And here I have 1, 2, 3 columns. So that's a 3 by 3 matrix. It actually is called a square matrix if we were going to do a whole unit over matrices. Number 2, number of rows, it only has 1 row, but it has 1, 2, 3 columns. So this is a 3 by 3, sometimes called a square matrix. Let's just make a note of that, just because if you take college algebra, pre-cal, you may do matrices, and you will be familiar with the words. All right, so number 3, let's see if we can determine how to write the dimensions of a matrix. So rows by columns, rows by columns. So I'm going to put my by in there. So I have 1, 2, 3, 4 rows, and I have 1 column. So that is a 4 by 1. In number 4, I have 1, 2, 3 rows, and I have 1, 2 columns. The numbers within the matrix, the elements, you can identify them with a lowercase letter and a subscript. So we have capital letter as our name for a matrix, so this one is A, and it's uppercase, and then the lowercase with a subscript identifies the element A within that matrix. And this is how this works. This is why you need to know rows by columns. So this first number is row 1, and the second number is column 3. So row 1, column 3, overlaps. So the element we're looking for is actually 3. So if I go to number 6, I'm looking for row 3, column 3. So row 3, this is 1, 2, 3, and then column 3 would be 1, 2, 3. So that would be 15. So number 7, you're looking for the element that is in row 2, column 1. So row 2, and then column 1, that would be 10.4. And then the last one is row 1, column 2. So row 1 and then column 2, that would be 24. All right, you can also add and subtract matrices. It's pretty easy. They do have to be the same size. So if I check the dimensions, this is a 1, 2, 1, 2, 3. That's a 2 by 3. This is also a 2 by 3. You can easily look at them and tell that they're the same size. So to add matrices, you simply add or subtract, depending on if you're adding and subtracting, their corresponding elements. So 1 plus 3 is 4. Negative 2 plus 9 is 7. 0 plus negative 3 is negative 3. 3 plus negative 9 is negative 6. Negative 5 plus 6 is 1. And then 7 plus 12 would be 19. So you just add their corresponding elements. With subtracting matrices, we're going to have two methods. Method 1 is adding the opposite. I've seen this used as a technique of teaching how to add and subtract integers in Algebra 1. Say you had 7 minus 10, and they taught you to add the opposite. So 7 plus negative 10 was negative 3. It's using double signs, which I'm not a fan of, but you certainly can do this method if it's easier for you. So I'm going to bring this matrix down. And I'm going to go from subtracting to adding the opposite. So the opposite of negative 3 is 3. Opposite of 1 is negative 1. The opposite of negative 2 is negative 2. And the opposite of negative 4 is positive 4. And then you're just going to add the corresponding elements. Negative 3 plus 3 is 0. 5 plus negative 1 is 4. Negative 1 plus negative 2 is negative 3. And 10 plus 4 is 14. Method 2. It's just subtracting the elements. And I'm going to show that inside a matrix. I'm just going to show my work area. So I could take 6 minus negative 4. Negative 9 minus 3. 7 minus 0. Negative 2 minus 6. 1 minus 5, and 8 minus 10. And then I'll do my math, arithmetic. Since I've got a 2 by 3, my size is going to be a 2 by 3 of my answers. 6 minus negative 4, remember that's addition. Negative 9 minus 3. 7 minus 0 is 7. Negative 2 minus 6 is negative 8. 1 minus 5 is negative 4. And 8 minus 10 is negative 2. So adding and subtracting matrices. There's something called equal matrices, and it can be really useful. Equal matrices are matrices that have the same dimension. So let's check that. So the same dimension. This is a 1, 2 by 1, 2. So it's a 2 by 2. This one is a 1, 2, and a 1, 2. So it is also a 2 by 2. Now we just need to see if they have equal corresponding elements. So negative 0.75 is equal to negative 3/4. 1/5 is the same as 0.2. 1/2 is the same as 0.5. And of course, negative 2 is equal to negative 2. Right, so if you understand the concept of an equal matrix, then if you are presented with a problem where they're telling you the two matrices are equal and you have to solve for x or y, then you just set the corresponding elements equal to each other and solve. So we're looking for x. So I see that x is here, and that would be equal to its corresponding element, 38. So then I can take x plus 8, set equal to 38, and then subtract 8 from both sides, and I would get that x is equal to 30. If I'm solving for y, then I find where y is located. So I can set negative y equal to, negative y is equal to 4y minus 10. So instead of moving the negative y over here, it's already by itself, and I'm just going to leave negative 10 there. I'm just going to subtract my 4y to the other side. Negative y minus 4y is negative 5y. That adds out. Bring down the negative 10. Divide both sides by negative 5. And y is equal to positive 2. So everything we've went over so far is pretty much in one of the problems on the ACT, so it combines a lot of these little concepts together, but we'll look at those in class together. All right, look at number 13. We're still doing the same thing. We're told these two matrices are equal, and we need to solve for x and y. So the first thing I notice is that 3x is equal to its corresponding element, negative 9. So that's easy. Solve or divide by 3, and you can solve that equation and get x equals negative 3. Now what I notice here is that 4 is equal to x plus y. So that means I'm going to have to use x to find y. So I'm going to take this negative 3 and put it in place of x. And then to solve for y, I'm going to simply add that 3 to both sides. 4 plus 3 is 7. Those add out, and so y is equal to 7. All right, one more little thing and we're almost done. The first time I recorded this, it took me like 25 minutes, so I was trying to get it down to a little shorter lesson. All right, you can solve a matrix equation. A matrix equation is just an equation where the variable is a matrix. It's that simple. So I'm just going to take this setup and show you what it looks like in Algebra 1. So if you had x minus 2 equals 8, you would just add 2 to both sides and get x equals 10. So this concept that you did in Algebra 1 is what you do here. So this is x minus this matrix, so to move it to the other side, we're going to add it. So those add out, and you have x equals 0 plus 1, 1 plus 1, 8 plus 3, and 9 plus 2. So you could also do that, the same thing if this was x plus the matrix, then you could subtract it from both sides. So you're using these basic procedures that you learned in Algebra 1. You can also multiply matrices. It's a little bit tricky, a little bit more complicated. We'll get into that in part 2 because you need some information to help you with some of the ACT problems. But the last thing I'm going to talk about is when you multiply a matrix by a real number, that real number is called a scalar. So it's scalar multiplication. So here you have 3 times this matrix. It's basically the distributive property. You're going to take this 3 and you're going to multiply it by everything inside that matrix. So 3 times 3 is 9. 3 times 5 is 15. 3 times 2 is 6. 3 times negative 1 is negative 3. 3 times 0 is 0. And 3 times 8 is 24. So it's the distributive property, and since this is a 3 by 2, you're doing it 6 times. That's the end of matrix part 1. You'll have a little bit of homework over that. I do have some ACT problems that we're going to talk about. Just to kind of give you a glance, scalar multiplication, equal matrices, and this one looks like it's ridiculous, but it has to do with multiplication, and we'll talk about it, and we'll make these easy for you. These should be the questions that you can get right on the ACT. So we'll look at those. So you do have a quick homework assignment over this. Good luck. Send me a message or an email if you have any trouble, and I will see you tomorrow.